Okay guys, we're going to have a look at an example here of a back titration. So back titration involves reaction of material of interest with a known quantity, both volume and concentration, of a reagent, and that reagent will be in excess. So effectively whatever the excess amount of that reagent that didn't react, we can then go back and look at what the concentration of the unknown is from that. So this example here is a pretty good example of that. So here we go. Laboratory technician conducted a test on some cloudy ammonia solution in order to determine the concentration of ammonia in the cleaner. So a 20 ml aliquot of the cleaner was transferred to a conical flask and mixed with 20 ml of 2 molar hydrochloric acid solution. So that's our known, and that needs to be in excess in this case. So the following reaction took place. So there's our first reaction there. So the solution remaining from the reaction, so that's the solution of the hydrochloric acid, was divided into 2 equal portions and each used to titrate with half a molar of sodium hydroxides, which will be the second reaction here. Sodium hydroxide solution using phenolphthalein as the indicator. The average titer obtained was 10 ml. So there's 2 titrations done there and they've got an average. Okay, so the equation for the reaction involved in the titration is shown below. Okay, so that's our second titration. Alright, so what we need first, what's asking us, and most of the questions we get in the exams will be stepwise, asking questions like we do in this example. Okay, so the first one here is calculate the number of moles of sodium hydroxide involved in the titration. Okay, so how do we work out the number of moles? So we've got the concentration and we know the volume. So the number of moles equals C times V. Okay, so here we've got number of moles of NaOH. Equals 0.500. Make sure you get your significant figures in there. Times, and we had 0.01. 0. So that's the 10 mils up here. 0.01. Okay, so the number of moles of NaOH equals, work that out, it works out to 5 times 5.00 times 10 to the minus 3 moles. Okay, so number of moles of sodium hydroxide involved in the reaction that's involved with our excess of hydrochloric acid is 5 10 to the minus 3 moles. Okay, so part B of the question asks, calculate the number of moles of excess hydrochloric acid that was present in one of the 2 equal portions that were used to react with the cloudy ammonia. Okay, so this is just working out our molar ratio. So we've worked out that the number of moles of HCl equals the number of moles of NaOH. Okay, so that equals 5.00 times 10 to the minus 3. Okay, so that's purely because we've got the same amount of moles in that reaction. So here we've got 1 mole and 1 mole. Okay, so HCl, that's our number 4. Excess, so that's the excess amount of hydrochloric acid that was present, okay, after the reaction. Okay, part C, calculate the total number of moles of excess hydrochloric acid remaining from the reaction with the cloudy ammonia. Okay, so in this case here, as you notice, they've divided that up into two equal portions. Okay, so the answer is basically going to be double what we've got there. So if you write this out, moles of HCl equals 5.00 times 10 to minus 3 times 2. Okay, because we divided that into those two equal portions further up in the question. Okay, so number of moles of HCl equals 1, that works out to 1 times 10 to the minus 2 moles. So that's the total number of moles of excess hydrochloric acid remaining from the reaction. Okay, so part D, calculate the number of moles of hydrochloric acid mixed with the cloudy ammonia. Okay, so the number of moles of hydrochloric acid mixed with the ammonia. So here we've got the number of moles. Once again, go back to the number of moles equals C times V. Number of moles of HCl just write that. Number of moles, space, HCl equals, so this is our 2 molar solution of HCl. And we had 20 mils. So if you look back up here, so 20 mils of the 2 molar hydrochloric acid. 2 molar times 0.0200. Fit that in. So the number of moles of HCl equals 4.00 times 10 to the minus 2 moles. So all up we've got 4 times 10 to the minus 2 moles of hydrochloric acid that was mixed with the cloudy ammonia. Okay, I've just lost that result, so I'll just put that back up here. So the answer to part D, just give me a second. The answer to part D, we'll put it back up here. So N of HCl, moles of HCl was 4.00 times 10 to the minus 2 moles. Okay, so now we're up to part E. So calculate the number of moles of hydrochloric acid used up in the reaction with the cloudy ammonia. Okay, so here we're looking at the amount of ammonia that was actually used at the beginning minus what the excess amount of hydrochloric acid. Okay, and that tells us how much actually reacted with the cloudy ammonia. Okay, so as per above, the number of moles of HCl used equals the number of moles of HCl initial minus the number of moles of excess HCl. So about that writing. Okay, so what we started out, we had a large amount of HCl which was in excess, so that's our HCl initial, and we're taking away what was in excess. So anything left over between that is what reacted with the ammonia. Okay, so that equals to So from the answer above, 4.0, 4.00, that's our total ammonia times 10 to the minus 2, total HCl I should say, minus 2, minus our excess, which was 1.00 times 10 to the minus 2, and that came from our excess, so number of moles of HCl in excess, trying to find where that came in, so that was part C. Okay, number of moles of excess hydrochloric acid remaining. Lost my spot there. Okay, so that then gives us our answer, part E of 3.00 times 10 to the minus 2 moles. Okay, so that's the number of moles of hydrochloric acid that has reacted with the ammonia. So now we just work out how much ammonia does that add up to. Okay, so how do we do that? Then we know that we work out what's our molar ratio. So if we went back up to the top, our molar ratio of ammonia and hydrochloric acid from reaction 1, if you look back at that in the video, it's a 1 to 1. Okay, so basically it's the same amount. So the number of moles of ammonia, I'll write it out, NH3 equals the number of moles of HCl used. So therefore it equals 3.00 times 10 to the minus 2 moles. Okay, and then part G asks calculate the concentration in moles per litre of ammonia in the cloudy bed cleaner. So in the cloudy ammonia cleaner, I should say. Okay, so concentration. So concentration equation is number of moles over volume. So that equals our number of moles we worked out is 3. From the above one, 3.00 times 10 to the minus 2 divided by, and if we go back to the question, it says a 20 ml aliquot of cleaner was transferred. Okay, so that was our back from the question, so we divide that by 0.02 for 20 mils, and we get an answer, the concentration of NH3 equals 1.5 times, that's right, 1.5 moles per litre. Moles per litre. Okay, so all up we had 1.5 moles per litre of ammonia in our sample with that indirect, with that back titration activity.